When you're actually noticing measurement error, there are several types of measurement error, as the example we showed you in the last video shows. There's random error and there's systematic error. And so random error is essentially these chance fluctuations in measurement. And that's kind of what we were talking about in the last video, the very end of the last video. No matter how precisely you measure things and how precise your instrument is, there's always going to be these chance fluctuations. Pressure, things blowing, your hand shakes, the instrument's cold, whatever it may be, there's going to be these small chance fluctuations. The more precise it is, the less likely you're going to have any large measurement changes, but you're going to be actually able to see these chance fluctuations even more. So random error means it's just randomly fluctuating up and down. It goes in both directions. It's not always in the same direction. And so the way to address random error is you basically are going to average across many trials, and when you average across them, you're going to get close to the exact value. Over and over and over again, we talk about why large sample sizes are important. One, it's to actually more capture what, like if you've got a certain set of participants, it captures the larger the sample, the more likely it is that they're going to be reflective of the population. But then also, as we're going to be talking in this, like if you're having people and you've got a weird person behaving weirdly, if you have a small sample, then that one point, that data point, is going to pull the means in a particular direction. But if you have a lot of people, the influence of one person isn't going to matter as much. And then also here, if you have multiple measurements or multiple people, this means that if you average across them, you're going to come closer to what the normal average value is. And so when you're measuring something, we were talking about people, but when you're measuring something, averaging or having more than one trial gets you closer to the exact value that you're looking at if you're dealing with random error. The other type of error is systematic error, which is known as a bias. It is a measurement that always is going incorrectly in the same direction. So in the example here, so maybe this was not calibrated correctly, and it's always, like, ignore this one. But let's say this is like 5 points higher than it should be, and it needs to be recalibrated. So this would be random fluctuation if you had these two different measurements, and that kind of happened over and over again. Maybe you take the blood pressure more than once. In fact, my doctor actually, the nurse actually took my measurement twice when she did it yesterday. I don't know why. She didn't like the first reading, and so she's taking multiple ones. But if you're having a bias, it's always going to be in the same direction. So in this case, it would always be 5 points high. So this is a systematic error. It's always pushing it in the same direction, which means that the systematic error does not disappear across trials. It's going to be there. So you eventually end up, eventually, it's like when you look at the data, it's going to look like it's 5 points higher than it actually is, but you don't know it's 5 points higher. You assume that's the true value. And so we kind of talked a little bit about this with social desirability when we were talking about rating scales and the social desirability bias. And so think about it a little bit. So remember what the social desirability bias is? That's the wish to, when you're being asked questions, to respond in a way that makes you, that's not accurate, but makes you look good, or the way that you expect people for you to respond if you're a good person or proper person. So think a little bit about that. Is the social desirability example of social desirability bias, is that a random bias? Or not bias, is that a random error, or is it a systematic error, which would be a bias? Right? In fact, it's actually, if you said it's a bias, it's a systematic error, then you are actually correct. Is that social desirability bias is this tendency to overreport socially desirable characteristics or behaviors in a self. And then also you have this counterpoint where it's underreport socially undesirable characteristics of it. And so if it's something desirable, you're going to see higher scores through everybody. And if it's something undesirable, you're going to see lower scores. Like, of course I wouldn't do that. And so that's a bias. That's why it's called the social desirability bias, is it's pushing in one direction or the other direction. So even though reliability and validity are tied together in terms of things like this, we're going to start with a discussion of reliability because it seems most, you could tie into it better when we're talking about the types of errors that we were just discussing. So what reliability is whether a measure yields the same results every single time you apply it. A yardstick is actually a good example of a reliable measure. Every time you measure the same object with the same yardstick, you would expect to obtain the same results. If you measured the height of a table and one day it was 21 inches and then you measured it again the next day and it was 19 inches, you probably wouldn't blame the yardstick for doing that. You would either assume the differences were due to the person doing the measuring, or somebody had come in and like cut off the legs a little bit or ground them down to cause the 2-inch difference in height. Now, of course, in psychology and a lot of other things having to do with people, we don't use yardsticks, not typically, to measure behavior, but the principle is essentially the same. Whether we use the Rorschach, an MMPI, a reaction time measure, we expect any changes in a person's score to be due to changes in the person, not changes in the test itself. For example, if I took the GRE and I received 140 on the math section, which is not a good score, and took it a month later and received 150, then the reason had better be because I studied the material in between the tests, or I was feeling better. Maybe I came in and I was incredibly sick the first time I took it, or I'd conquered my test anxiety. The GRE is supposed to be a reliable measure, so you shouldn't see a 10-point jump unless there were some mitigating circumstances in the first test that were fixed in the second test. So if the measure you are using is reliable, this is going to be the case. If it's not reliable, you're not quite sure whether, like in the case of the GRE, those changes were due to a change in the person or changes to a bad test.